Let's talk about user-defined function and store procedure. So far, we have learned a lot of functions in PostgreSQL. Functions in general provides a result based on the given input. It can be raw level function, it can be aggregation function, it can be Windows function, but basically you give them one input, one row of input, or one multiple rows, one data set of input, and they give you back respective results. They can be used in SQL statements to provide complex data processing functionalities and logics. For example, like upper, right? Once you have the uppercase, you can convert everything, every string into the uppercase counterpart instead of using case every time. Oh, is it a lowercase a? Then convert it to uppercase a. You don't need to do that all by yourself. Instead, Postgres provides you with this function. You can also write your own function because the functionalities provided by PostgreSQL and all other DBMS, no matter how comprehensive they are, is always limited. There are always some your specific requirement or your specific logic they cannot cover. So you can define your own function. They provide you with the ability to create your own function. If the functions provided by the DBMS, being it the PostgreSQL or other DBMS, do not meet your need, it's similar to the functions provided by PostgreSQL. You will just call them from your select statement and expecting a result. But these functions are defined by you, by the users, as a collection of SQL code where you will run through a SQL set, multiple SQL statements to generate the result. Of course, you can just use one single SQL statement in the function, but if it's just one single simple SQL statement, there's no reason to create this function. You directly use the SQL. Wouldn't that be easier? So usually, user-defined functions are a collection of several statements, and including certain logics, branching and looping, all these things, and provide so that it can provide more complex functionalities than what you would expect from a Postgres system for SQL or one simple SQL. And all the functions must return a value, right? You provide the function with some input, with some rows of data, with a data set, and you expect the function to provide you something back. This will be returned with a return statement. So this is a definition of a user-defined function. The first few words, the first few rows looks straightforward, right? Create function. We already see create table, so we can safely assume that the create function does the same thing. It creates a function with a function name and the parentheses with arguments. This is just like the PostgreSQL defined function. You will provide your user-defined function with a series of arguments that it can be used inside the function to generate the output, then followed by the returns clause. Returns clause define the return type. Then this return type is just a regular data type you would expect: integer, varchar, boolean, everything you would expect in a simple create table statement, similar. But of course, you can only return one data type. One function returns one data type. And then it followed by the S statement, S clause. And we will discuss about this S, but basically you will have your function statements here. And you can see other components, $, begin, end, declare. We will discuss this in the next few slides. And finally, once you define the function name and return type and statements, you will define the language, right? Language usually is a PLPG SQL, which means PostgreSQL. You can define functions with other language. However, this is beyond what we will discuss. If you are interested in that, you can definitely consult the Postgres documentation for further information. So first of all, we will have the create function in create function statement, the clause. Where you define the function name. Function name will be the same as the the naming convention will be the same as other functions, other objects like tables or views. You can also add or replace after create, just like what we talked before. You can do a create or replace function. So if this function exists, then you will replace it without failing the SQL, without giving you an error message. And this can be useful when you are creating this function dynamically in the script. However, as always, when you have this kind of functionality, this silently replace the code, replace the object. Always be careful, because you may accidentally overwrite something that has been using, and nobody and other people don't expect it to change. So while it's useful, be careful on the side effect it may cause. Then you have the function arguments. We always have a function arguments for all row SQL, right? We have a count statement, then we have a count function, then you have the count column, count star. All these are function arguments. These arguments can be used in the function statements later, and it follows when you define this argument, you have to do argument name followed by argument data type, just like what we will do in the column definition for in a create statement, right? For example, I name varchar. I name varchar 10. I name varchar 5. ID, integer. These can all be arguments, and you can also have multiple arguments in the list. In this case, the multiple arguments will be separated by comma. And then the second row in the definition is the returns data type, right? And we already talked about this. You will do a returns varchar or a returns integer, something like this, to define the data type that the function returns. Now, talk about the S clause. S clause or S block is used to define the function logic. Now, it starts with the keyword S, then followed by the $sign. $sign is a identification code to identify a block, a boundary of an S block. It just tells the PostgreSQL where this statement block starts, where it ends. And $sign can also have a name like this, $my code block and $my code block. This is useful when you try to make your code more readable. And then inside $block, you have a declare clause. Declare clause defines a variable that's going to be used in the function. Again, these variables are similar to arguments, just that they only exist within the function, right? They can be used somewhere in the statements to temporarily store a value. It will be defined the same way as the column definition, as well as function arguments, that it's a pair of variable name and data type combination, like I affiliation, varchar, instructor affiliation, varchar, or instructor ID integer. And inside, right after declare, once you define the variable inside the S block, you will have a begin and pair. Begin and pair tells PostgreSQL this is a complete transaction block, that things inside this block happens all together. It defines the execution within this begin and the block. You have the function statements, a bunch of one or multiple SQL statements separated by a semicolon. It defines the execution logic used in this function. And at the end, or somewhere inside the statement, you must have at least a return statement, returning a value that has the data type defined in the returns block. So whatever you write in the return statement, you must have a data type that's the same as what the returns block defines. And finally, we have the language part, language clause, where it defines the language used in the function. Usually it's a PLPG SQL. Now this block in our particular case, we put them after S block, but it can also optionally be placed in front of AS block. Okay, so when you try to write a coding block, when you try to write your function, you first of all copy this over, copy this framework over, then replace function name, replace function argument and the return type with your definition, with your desired output. Then after that, you will use SQLs with variables. You will insert, update, delete, doing all these operations in functions. Usually you don't do select unless you are selecting into a variable, right? Because insert, update, delete, these are actions, but select are just getting data out. You only want to get data out into a certain variable for later usage. But then eventually you will return a variable. Select into a variable, select a value, the final result into a variable, and the return, and you use the return statement to return it. Now, when you use SQL, try to avoid creating permanent objects in stored procedure. Try to avoid creating tables. Try to create we talked about non-permanent objects, right? We talked about like temporary tables. Try to use this temporary tables or CTE instead of using permanent tables. Because if you create a permanent table, what if someone else happens to create the same name, a table with the same name or an object with the same name, right? So in this case, it will be much painful to do this to using permanent table. But by using a temporary table, you will avoid all this trouble. And then you don't need to drop these tables explicitly. Instead, you will just run once, and so you only need to run create once, and the PostgreSQL will drop the table later on once your session is closed. And finally, if you need to output some message, you can use a statement called raise notice, which we will cover in our SQL demo. Similar to functions, there are something called store procedure. Store procedure is almost identical to SQL, to function, as you can see that you can create with S block, with language, but store procedure does not return a value. That's the only difference between store procedure and the functions. It does not return a value, but it does receive, accepts arguments from you, from whoever calls this procedure, and it will declare variables and will return and will run a set of statements. It's the same as a function, just not returning value. They are function store procedures are very important. They are a significant part of SQL usage. I think it's safe to say like 30–40% of SQL usage is in functions and store procedure. Another 30–40% is in data warehouse querying, which we will cover in a later session. But basically, you can see that this is almost one most important part. So if you are interviewing for a more advanced, like mid-level SQL developer's job or a system analyst job, they will definitely ask you to write something, to write a function or store procedure. So make sure you understand that. Now, the trick part of this is a function code or a procedure code. How you define those? We already said it's about SQL, but it's an extension of SQL. So there might be some extensions that is unique to each DBMS. Whatever works in PostgreSQL may not work in SQL Server or Oracle. So this is a DBMS by DBMS. You have to be familiar with one DBMS, but in addition, you need to notice that the fundamental logic, the idea of using SQL function to provide some functionalities is universal. So this is what you want to deliver to your interviewee when you are to your interviewer when you are working on interview. Even if you are not familiar with database DBMS that the company want to use, you want to show them that you understand the basic idea of function, and you understand how to write functions in Postgres. So I believe most of the individuals will understand that it's easier once you know how to do it in one DBMS. It's easier to convert to another one.